Everyone and welcome. So far, you have learned a lot of things on Solidity. I know it can be a little bit hard to understand just by reading it. So again, I recommend you to practice a little bit on your own using Remix IDE. But for today's lesson, I'm also going to demonstrate you a smart contract where we can put a lot of things that we have learned during the tutorial in practice. First of all, this smart contract will develop a basic idea. So it's going to be like a PayPool, meaning that instead of paying directly to employees, the employers can use this smart contract. Okay, the idea is simple. We have a pool, and with this pool, we are going to give allowance to the users so that they can come and claim their tokens from the pool. And also, we are going to have addresses that can deposit tokens to this pool. So we are having deposits to this pool, and from this pool, we are giving allowance to people so that people can retrieve their tokens. This is actually a very simple idea, but we are going to see a lot of important concepts. You will understand it in more detail while we are doing it. Now, as you can see, I'm in the starting page of the Remix IDE. I'm going to go to the contracts, let's say in file, and I'm going to call this paypool.sol. Now we have our empty contract. Now let's start. The first thing that we are going to do is we are going to give the license. Next, the version. And now we are going to have just one import. Let's say imports here. We are going to use this import to actually safely retrieve tokens. As you may see in the tutorial that there's a problem called reentrancy attack. So reentrancy attack basically means that a user is trying to get some token, and before we update the blockchain, it requests again. And since the blockchain is not updated, then we are giving the token again. After we give the token, if we are not fast enough to change the data on the blockchain, they can actually come back and ask it again. To get rid of this error, we are going to use a contract from OpenZeppelin called Reentrancy Guard. It's a very common contract. Also, it will demonstrate how we can use other contracts in our contract. Now let's start our contract by saying contract PayPool, and we are going to say it's Reentrancy Guard. Since we are using this Reentrancy Guard, we are going to inherit from the Reentrancy Guard so that we can use its functions. And in our case, we are just going to need a modifier. Let's start with the data section, which is going to involve the data in our contract. The first thing that we are going to need is, let's say, uint public total balance. So this will be the total balance in the contract, and the owner of this contract will be able to retrieve tokens from the contract, but the owner will not be able to retrieve tokens that has been given as an allowance. Let's say I have 10 Ether in this contract, and I gave 1 Ether allowance to one address and 1 Ether allowance to another address. Amount that I can retrieve from the contract is not 10, but it's 8 because I'm subtracting the 2 Ether that I have allowed to other users. Total balance is going to be the balance that I can retrieve. Next, we will have the public address owner, and we are going to have a public array of deposit addresses. So these will be the addresses that can actually deposit tokens to this smart contract or this PayPool, let's say. We will have a mapping, and this mapping will hold the allowances. So for that reason, let's say mapping address. So we are saying address on the left-hand side because we want address and the amount of token that we gave as an allowance, which will be uint or uint 256, which is the same thing. Let's call this allowances. Now that we have our total balance, our owner, the addresses that can deposit, and the allowance mapping, it's time to create our events. I suggest you create the events in the beginning of the smart contract because when I actually started writing Solidity, I was doing these event things at the end. But after a couple of contracts, I realized that if I put events in the beginning, then it gives me a whole idea of the structure or how I'm going to structure this smart contract. So for that reason, I suggest you start with the events, but you can do whatever is more suitable for you. Now, let's say deposit as the first event. We are going to say address, index, and this index keyword means that we can actually filter using this variable from the front end. So that's why we are putting index. I'm going to say depositor, and one more thing, let's say amount. From the front end, we will be able to filter this based on depositor, not based on the amount, because we use index keyword with depositor, and we can use index keyword once per event. The next one is address edit. This event will be emitted once we add a new deposit address to our deposit addresses array. Now, this is for the address that has been removed from the deposit addresses array. Now, this will be for the allowance that we have given to a user, and the counterpart is allowance removed. And finally, we are going to say funds retrieved. Now we have our events. Let's create the modifiers. I think this is the best part for me. I really like modifiers. So because again, to actually type or write the modifiers, you need to know what you're gonna do. So it helps you to imagine the smart contract in your mind. And also it really saves a lot of time. So let's start with something, let's say very usual. I'm going to call is owner. We are going to require message.sender is equal to the owner. If not, we will say not owner for short. So the next modifier will be got allowance. This will take a parameter, let's say this is user. So with this got allowance, we are going to check if the given address has the allowance or not. Because in many situations, we want to able to perform something if the message.sender has the allowance. And for that reason, we are going to use this got allowance modifier. Let's say require. I'm going to say has allowance here. So it's going to give me an error because there isn't a function called has allowance. But after the modifiers and the constructor, we are going to create these functions. Say user, the idea will be is that this has allowance is going to return true. If the user has the allowance, it's going to return false if the user does not have any allowance. And for that reason, it's going to return true, and then there will be no problem. But if it's going to return false, then we are going to fire up this message saying that this address has no allowance. Now, the next modifier, let's say can deposit tokens, and with the same ideology, we are going to check if the given address has the capacity or has the permission to actually deposit tokens to the smart contract. Let's say require can deposit, and again, we haven't created this function, but it's going to work as the same with the has allowance one. Let's pass the depositor. This address is not allowed to deposit tokens. I think this all are modifiers. And if we're going to need more, then we are going to come back and create a modifier. In general, I create the modifier even if I'm going to, check once. It can be a good practice to see, but in reality, if I'm creating professionally, if I'm going to say require something in a function, then I don't create the modifier. But if I use it more than once, then for it, I create the modifier. But again, this is your way. You can do however you want. Now let's say constructor. And we are going to say payable because I want to be able to retrieve some tokens with this constructor. So once our smart contract has initiated, then I want to be able to pass some tokens with this initiation. So it's okay if I don't pass any tokens, but I want the ability to initialize my smart contract with some tokens in the pool right from the beginning. I think many people would want, right? Let's say total balance equals message.value. And this message.value is going to give us the amount that has been passed with this transaction. And then we will say owner is the message.sender. So whoever initializes this smart contract will be the owner of this smart contract. In many cases, it's fair. Now we have completed our data part. If we look quickly, we have our reentrancy guard contract. We don't know exactly how we're gonna use it, but we know how to inherit from it, and that's using this is keyword. We are going to say contract PayPool is reentrancy guard. Then we have our data section. we have our total balance and the owner, which are public variables. Then we have deposit addresses, which will be the addresses that has the permission to actually deposit some tokens to our pool. We have allowances, which is a mapping. And on the left-hand side, as the key, we have the addresses. And on the right-hand side, we have uint 128, which will be the amount of tokens that this address will be able to retrieve from the pool. Then we created our events, which will emit with our execute functions so that the front end can know what's happening. We can actually log the events actually, or what happened in the smart contract. And we said that we can filter each of this with this index keyword. In the beginning, for the deposit, we will be able to filter this using this depositor. For each one, we are going to use the variable which is assigned with this index keyword. Then we said that we have our classical modifier, and now I called it is owner, but the idea is same. You may say only owner. We have this got allowance, which is going to check if this given address has the allowance or not. And for that, we are going to create a function. At this time, we don't have the function. That's why we have this red underline. Finally, the final modifier actually have the can deposit tokens. This is going to check this very similar thing, but not allowance. Instead, it's going to check if the given address can deposit some tokens to the PayPool. And finally, we have our constructor, which is payable, because I have to say it's payable so that I can retrieve some tokens. Inside this constructor, we have total balance, which where we get the value from the transaction, and we have the owner where we get the message that sends the address that has sent this transaction, which will be the owner of this smart contract. Thank you very much for sticking with me so far, both in the tutorial and in this video. And in the next part, we are going to create the functions that we are going to use in this contract internally. So again, thank you very much and see you there.